See, we can find the roots of a quadratic equation in more than one way. And in the examination, sometimes the question will specify the method by which you can find out, or you should find out, the roots of the quadratic equation. One of the methods that we'll be learning in this particular video is finding the roots of the quadratic equation by the method of completing squares. So if they mention this, then you can't use the quadratic formula. You cannot factorize it even if it is factorizable. You need to use this method to find out the roots. Let's get around to doing that. We'll start with a very simple example. Understand what this completing squares business is all about, and then find out the roots for this using the completion of squares. Then let's enumerate the steps that are required. It's a 5-step process to find the roots of a quadratic equation using the completing squares method. Lastly, we'll pick up 2-3 examples, consolidate what we have learned. Let's get started. I'm going to be starting with something very simple. Remember this equation. This is our objective as far as this question goes. We need to find the roots of x square plus 6x minus 30 equals 0. But we're not going to start here. We're going to be starting with something very simple. X square equals 4. So if we had something as simple as this, what is the value of x? Value of x is x equals 2 or x equals minus 2. So that x square plus 6x minus 30, I'll write it here just for our reference, x square plus 6x minus 30 equals 0. If I can somehow write it to resemble some y square on the left hand side and some term on the right hand side, let's say a 40, then we can say y is equal to something or this x is equal to something and find the answer. So our objective is to make this look like a square on the left hand side. This is very simple, x square equals 4. What if this had not been a perfect square? If you had something like x square equals 5. We know how to find the value of x here also. We're going to be taking square root on both sides. So value of x is going to be equal to root 5 or value of x is going to be equal to minus root 5. This was also quite easy. What if we did not have square of x and had something like square of x minus 2? All that we're going to do is we're going to be taking square root. So we'll get the value for x minus 2 to start with. X minus 2 is going to be equal to under root 5 or x minus 2 is going to be minus under root 5. What is the value of x? Value of x is, take this minus 2 to the right hand side, will become 2 plus root 5 or the value of x is going to be equal to 2 minus root 5. So till this point, we are on familiar territory. Let's quickly summarize it till this point before we move to the next example. If it's x square equals 4, very straightforward, the value of x is plus 2 or minus 2. If it is a 5, which is not a perfect square, we know the answer is going to be an irrational number. Still we can find out it is under root 5 or minus under root 5. What if it is an x minus 2 the whole square equals 5? Find the value of x minus 2 first. That's going to be equal to root 5 or minus root 5. From there, deduce the value of x, which is 2 plus root 5 or 2 minus root 5. Let's look at one more example. What if we had something like x plus 3 the whole square equals 39? Very similar to this. Pause the video, find the value of x, and then we'll start the discussion. Did you find the value of x? Quite straightforward. Let's take square root on both sides. We'll have x plus 3 equals root 39. Or x plus 3 equals minus under root 39. So value of x will be equal to, take the 3 to the right hand side, we'll make it as minus 3. Minus 3 plus root 39 is one value of x. The other value of x is minus 3 minus under root of 39. So no difference between the fourth and the third example. Before we close this example down, let's do one very simple exercise. Let's expand the term on the left hand side and see what we get. The term on the left hand side will expand as x square plus 6x plus 9, this equals 39. Take the 39 to the left hand side. So what will we get? We'll get x square plus 6x minus 30 equals 0. Isn't this the equation that we started this entire video with? We were supposed to find out the value of x by the method of completing squares for this. So x square plus 6x minus 30 equals 0. The preceding step, what was it? X square plus 6x plus 9 equals 39. This is x plus 3 the whole square and that is equal to 39. So we can find the value of x to be equal to minus 3 plus root 39 and minus 3 minus root 39. So if this is our starting point and if we went ahead and did this process of completing squares, we would have got something like this. And from there, we could have got the value of x without batting an eyelid at all. The question is, in this case, it was easy because we started from here and we realized it's the same as the original equation that we had. What we are expected to do is keep this as your starting point and get around to reaching this completed square form. So how do we go about doing that? Let's see it in the next slide. Before that, let's quickly summarize this discussion before we go to that. The value of x is minus 3 plus root 39 or minus 3 minus root 39. There's nothing to discuss in this part. Then we went ahead and expanded this equation. What did we get? We got something which is similar to what we saw. The same equation, which is x square plus 6x minus 30 equals 0. If this is a starting point, getting here is no sweat at all. But the problem is, this is a starting point and we need to write this as x plus 3 the whole square equals 39. Once you can write it this way, getting to this is just the next step. It's just one step to get there. So let's see how to write this x square plus 6x minus 30 or any such equation into a completed square form. Let's get started. What we are going to be doing is, we're going to write any x square plus bx plus c as a completed square, x plus p the whole square plus a q. Once we can do this, then we can take square root on both sides. Let's expand this x plus p the whole square. What do we have? We have x square plus 2px plus p square. Let's compare these two terms. X square and x square, nothing much to do there. The 2px here is equal to bx. Our objective is to write it as an x plus p the whole square. So we need to find out the value of p. Have we found out the value of p? For us, 2p is equal to b when we compare these two equations. So finding the value of p is very straightforward. P is equal to b by 2. That's a starting point. First step, always write any equation. If you had an equation which says 4x square plus 7x, write it as x square plus 7 by 4x. Let's say this is equal to plus 4 plus 1. Write the equation in the form x square plus bx plus c. The coefficient of x square should be 1. Having done that, let's find out the value of p, which is going to feature as a part of x plus p the whole square. We compared these two equations and realized that 2p is the same as b, or p is equal to b by 2. That is step number 2. So we're identifying the value of p. P is equal to b by 2. That is established. 2p equals b. So p is equal to b by 2. Let's get around to our example. What is b? B is equal to 6, which means 2p is equal to 6. P is equal to 3. So we are going to write our x square plus 6x minus 30 equals 0 as an x plus p the whole square, where p is equal to a 3. So we will be writing x square plus 6x minus 30 or whatever. This part, don't worry about it. This should essentially be written as x plus 3 the whole square. How did we get this 3? 3 is the value of p. How did we get the value of p? P is always equal to b by 2 if you write the equation in the form x square plus bx plus c. So you got the value of p as p equal to 3. So this x square plus 6x minus 30 is what we have. Let me expand this term first. This is going to be x square plus 6x. Till this we are on even terms. Plus a 9 is what we have. I actually need it to be a minus 30. So I'm not going to do too many stuff. All I'm going to do is, we added a 9 from here as a p square. Let me subtract a 9 and then subtract a 30 and finish this. Are these two equations the same? X square, 6x, 6x. 9 and minus 9 will get cancelled to leave us with a minus 30. So these two equations are one and the same. So write it as x plus p the whole square. This is your x plus 3 the whole square. Subtract a p square from it, minus 9, minus 30, and finish this entire equation. So how does this look like? Now this becomes x plus 3 the whole square. Minus 39 goes to the right hand side as plus 39. From here, finding the value of x is a very, very simple step. Let's quickly run through this once more. List down the steps and do few more examples to consolidate it. Right? So the idea is to write this x square plus 6x as x plus 3 the whole square. How did we arrive at this 3? This is no magic. This 3 is nothing but always this b by 2. Here b is equal to 6. So 6 by 2, we are going to be writing this as x plus 3 the whole square. By writing it as x plus 3 the whole square, expansion of x plus 3 the whole square has a plus 9 term. Because we are adding a 9 in the form of p square, we're going to be subtracting a 9 from it. We added a 9, we subtracted a 9, and the initial minus 30 stays with it. What is this part alone? This portion, the first 3 terms are x plus 3 the whole square, which is what we wanted. We subtracted a 9 to keep the integrity of the equation unchanged. Minus 30. Minus 9 minus 30 is equal to a minus 39. This finally becomes x plus 3 the whole square equals 39. This was our starting point for the previous slide to find the value of x. So what are the steps involved in doing this? First step, rewrite any quadratic equation in the form x square plus bx plus c. That is, make the coefficient of x square to be equal to 1. If it is already a 1, you don't need to do anything. This step is not warranted then. Step 2, find out the value of p. P is always equal to b by 2 in this. Step 3, add and subtract a p square. add a p square, subtract a p square. This part of the equation is essentially going to become x plus p the whole square. Take this minus p square and c to the right hand side. You'll have p square minus c. Take square root on both sides. Find the value of x. That's all is there. 5 steps. First step, if the coefficient of x square is not 1, make it 1 by dividing the entire equation by that. Step 2, find out the value of p, which is nothing but b by 2. Step 3, to this equation, add a p square and subtract a p square. You'll end up with the equation which is going to look like x plus p the whole square equals p square minus c. This is going to be step number 4. Take square root on both sides, you'll get the value of x. We'll do few questions to consolidate this. In these examples, I've kept it very simple. In all of these cases, I've kept the coefficient of x square to be equal to 1. So step 1 is not to be done for any of these. I'll do the first one, pause the video, try out the second and third, then we'll discuss all of them. In this case, what is the value of b? b is equal to 10. p is always equal to b by 2. So it's going to be equal to 10 by 2, which is equal to 5. Compute the value of p square equals 25. So what are we going to do? We found out the value of p, that is step number 2. We found out p square. Now to this equation, add a p square and subtract a p square. So we'll get x square. This is step number 3 for us. This is step number 2. This is step number 1 because we don't have to do the original step number 1. So we're going to be writing it as x square plus 10x plus p square minus p square and then whatever we had, which is a plus 11 equals 0. This part is nothing but x plus 5 the whole square. Minus 25 plus 11 is a minus 14 equals 0. Take the minus 14 to the right hand side. You'll get an equation which is x plus 5 the whole square equals 14. This is this entire quadratic equation written in a completed square form. Now all you have to do is take square root, take the plus 5 to the right hand side, find the answer. Our objective is to always stop here. Don't worry about it. In the exam, you'll have to do one more step to get to the answer, but we'll do this exercise to this. So get to this point for these two equations, then play the video and then check out whether our answers match. Did you guys complete it? I'm going to quickly wrap it up. What is b for the second equation? b is equal to minus 6. So what is p? p is equal to minus 6 divided by 2, which is equal to minus 3. Step 2, I'm going to be computing the value of p square. If p is minus 3, p square is equal to 9. I'm going to add a 9, subtract a 9 to this equation. So you'll have x square minus 6x plus 9. I've added a p square. I'm subtracting a p square. And then we had a 21 in the equation initially. So let's leave it as it is. What is the first three terms become? They are essentially nothing but x minus 3 the whole square. Minus 9 plus 21 is equal to plus 12, which is equal to 0. So x minus 3 the whole square equals minus 12. Third one, what is the value of b? b is equal to 8. So value of p will be equal to b by 2, which is 8 by 2, which is equal to 4. Next step, find out the value of p square. P square is equal to 16. So to this equation, x square plus 8x, we're going to add a 16, subtract a 16. X square plus 8x plus 16 minus 16 minus 20 equals 0. This part is nothing but x plus 4 the whole square. Minus 16 minus 20 is a minus 36 equals 0, or x plus 4 the whole square equals 36. Quickly done all of these in a printed form. For the first equation, it ends up being x plus 5 the whole square equals 14. Second one, we computed the value of p to be equal to minus 3. Add and subtract a p square, which is minus 9 plus 9 added and 9 subtracted to result in x minus 3 the whole square equals minus 12. In the last case, b is equal to 8, so p is equal to 4. P square is equal to 16. Add 116 and subtract 116 to this equation. So we'll have x square plus 8x plus 16 minus 16 minus 20 equals 0. This portion is nothing but x plus 4 the whole square. Take this to the right hand side, you have a plus 36. Going to recall and recap those 5 steps again. In any quadratic equation, rewrite it in the form such that the coefficient of x square is 1. Now we have a b and a c. Using this, we're going to be computing the value of p. p is equal to b by 2. Step 3, add a p square and subtract a p square. So you'll have x square plus bx is nothing but 2px plus p square minus p square plus c. This part of the equation is x plus p the whole square. We're taking this entire thing to the right hand side to result in p square minus c. Take square root on both sides to find the value of x. Right? That's all is there to completing squares.
Supercharge your math quotient. Sign up today for online CBSE math classes at online.maxtute.com. I'll repeat it. It's online.maxtute.com. And before you leave, check out the related videos and remember to subscribe to this channel.